Hi, greetings. My name is Karan Tonge. Today we are going to learn the fundamentals of Java programming. Let's get a quick overview of what we are going to learn in this tutorial. First one, the general idea of what Java programming is. Second, how that stuff works. Third, the advantages of Java programming over several other languages into the object-oriented family. Fourth, this basic syntax is covered under Java. Fifth, Java methods and classes, and sixth, stream manipulation. The content specified over here will help you get up to speed to learn Java programming, and in our succeeding tutorials we will be getting a deep idea into Java programming. Let's begin with learning the fundamentals of Java. Okay, so Java is known as write once and run anywhere language. That means it is a platform independent programming environment into which the programs developed in Java programming can be run on any platform. Let's know about it in detail. So, according to the agenda, the first part we will cover is the general idea about Java programming. So, what is Java? As said, it is a platform independent programming language. It is quite similar to C++ in syntax. So the students or the professionals who are well versed in C++ will find it very easy to learn Java. Similar to Smalltalk in mental paradigm. Of course, each and every thing in the world has pros and cons. So Java comes with the pros as follows. It is ubiquitous to internet. We can develop a networking applications, graphic applications, rather core applications using Java. So it supports a wide range of applications. The cons you can say is Java is interpreted language and it is still under development. But nowadays, as the versions of Java are very, you can say, are deployed very fast, thereby the cons are very well covered into the upcoming Java versions. The next slide highlights some of the interesting features of Java. What are those? These are automatic type checking, automatic garbage collection, simplifies pointers. The most interesting thing over here is Java has no direct accessible pointer to memory. That means the pointer concept which we knew from C and C++ cannot be applied into Java. This adds upon more security aspects into this language. Besides, the automatic garbage collection helps you to manage memory during runtime. So the unused objects, unused variables, and unused memory allocations are automatically collected and freed whenever not required. Moving ahead, it provides simplified network access and multi-threading. We will get an idea about some of the interesting features into detail into our succeeding tutorials. So let's get an idea about how Java works. This is an internal representation of how the Java compiles the source code, converts it into a bytecode, and then returns you the output. So not going into much detail, but yes, making helping you to understand everything. I'll brief you through how the Java takes care of the programming environment. So over here, this is our Java file. Whenever we write a code in Java, we append the extension as .java. The Java source is taken by the Java compiler whenever we compile the code. After the code compilation, the compiler converts that code into a bytecode, and that file gets appended with the .class extension. So this is quite important over here. This class file, it makes your Java code platform friendly because this file contains your bytecode, which is understood by machine and into a binary format basically. So this bytecode is moved locally or through network into the class loader. So why we say Java is platform friendly is because of this bytecode. This is understood by most of the processing elements or machines. So When this class file is loaded, the bytecode verifier divides that file into two parts. That is, one is given to the Java interpreter and one is the just-in-time compiler. So all the error checking and other runtime issues are checked over here and later are delivered to the runtime system. In the meantime, if we have imported some of the external Java libraries, that gets added up to your code from from this external part. Later, the runtime system hosts your code into the operating system format, and the operating system converts it to your machine code. In this way, your Java generates the output. The whole part which we are seeing here, that is Java interpreter, just-in-time compiler, and runtime system, are the part of JVM, Java Virtual Machine. So JVM is quite important part over here. This is why the like this plays the main role of converting, or you can say saying your Java code to be platform friendly, because JVM is present on almost all machines where Java is installed, and this is the important key that converts your code, your bytecode, into a human readable output. So let's move ahead. So how Java works basically. As I explained you in the previous slide, just get a quick look onto that figure basically. So Java is independent only for one reason. Only depends on Java Virtual Machine. So as I said, on the machine, so where JVM is installed, each and every Java code will run on that machines. The code is compiled to bytecode, which is interpreted by resident JVM. So all the .java extension files, whenever you compile them, those are converted into .class files, which are nothing but the bytecode files, and those are interpreted by JVM. And the just-in-time compilers attempt to increase the speed. So whenever the interpretation is going on, it speeds up the things by reading everything line by line and reducing the burden of JVM. So Java is quite faster interpreter, you can say, compared to uh, other languages. Let's move ahead. Yeah, the important part that comes with each and every programming environment is security. So let me go back into C programming and C++ basically. In C and C++, we know we had the concept of pointers. Rather, C was just a procedure-oriented programming. So comparing C with Java might not be that relevant. Let's come to C++ and Java comparison. So in C++, though it provided all the object-oriented facilities such as polymorphism and inheritance, like all the other object-oriented languages provide, but it had one more thing that called as pointers. So pointers give you access directly to your memory locations, memory addresses, you can say, and it becomes quite insecure to get an access through a language into your memory. So though it is an object oriented programming language, C++, it cannot be called as pure object oriented, because the use of pointers makes, can make your whole program corrupt. So that's the reason in Java the concept of pointers is removed. So what pointer denial is, it reduces the chances of virulent programs corrupting your host. So we all know that viruses are nothing but, have the most role to play with pointers. So pointers can introduce virulent programs into your system. So Java is quite secure in that. Later, applets are even more restricted. The most interesting part over here is when we create applets in Java, or some of the graphics using applets in Java, so they may not be like, they cannot run local executables. Okay, they are not local executables. Then read or write to the local file system is not possible through applets. And applets run inside your browser basically, so they are not desktop independent applications. So communication with any server other than the originating server is not possible using Java applets. So this adds up to more security into your graphics applications if you are using applets. So let's move towards the next slide. So why Java is object oriented? Because it supports all the object oriented programming paradigms such as polymorphism, inheritance, encapsulation, data abstraction, data hiding, and etc. So Java programs contain nothing but definitions and instantiations of classes. Everything is encapsulated in a class. So let me just brief you through the quick idea about what polymorphism is, of what inheritance is, and what encapsulation is. These are the three main flags, you can say, of object oriented programming. So polymorphism can be explained with one example. Consider there are three entities. One is a human being, one is a bird, and one is a animal, a four-legged animal. So I will just give one command, move. So by this move command, human will interpret it as he will start walking. Okay, bird will start flying, and the four-legged animal will start running maybe or walking. So just with one command, several different parallel actions are being performed, and that too in their different forms. So polymorphism means nothing but many forms. So poly is many, morph is forms. So polymorphism is many forms. So that is polymorphism, and how we are going to achieve it in Java, we will see it into our succeeding lectures. Next is inheritance. Inheritance is nothing but reusability. In short, we need not create several different objects, or you can say several different repeatable code that may affect your memory management. So Java provides you with the option of inheritance where you can reuse your code again and again, reducing your memory usage and optimizing your space complexity. Next comes encapsulation. Just giving you a small example of how encapsulation is actually in object-oriented programming. Suppose I want to send a letter to my colleague or my friend. So how we generally do that? We write a letter and we do not post it into a post box directly, right? We put it into envelope, we seal it, and then we give it to the postman or post office, and then we do it. So that is nothing but encapsulation. In Java, whatever the things we do are compulsorily encapsulated inside a class. So nothing is open, everything should be accessed using the object of that class. So all the you can say the security in that aspect is maintained, and the integrity of your code is maintained. So that is a short example of encapsulation. We are definitely going to see exactly from Java perspective what it is in the succeeding lectures. So Java programs contain nothing but definitions and instantiations of classes. As I said, everything is encapsulated in a class. You cannot write anything outside class. So it is important to understand what are classes basically. Let's move towards the next slide. So before understanding what are classes and the methods of Java, so let's get a quick overview of the advantages of Java. As we have come so far, we have learned a lot of techniques and a lot of several different pros of Java. So let's summarize them. So Java is portable language. Write once, run anywhere. You can write on any machine. Just you will generate a bytecode and you can run that bytecode anywhere. Security has been well thought through. It has a robust memory management. It is designed for network programming. It is multi-threaded, that is multiple simultaneous tasks. So uh, most of the languages like before Java, they lack the support of multi-threading programming basically. So in Java, you have that facility of computing multiple tasks in parallel. So that is one of the flagship features of Java, and that is what makes Java a dynamic and fast language. Next, it is dynamic and extensible. It has loads of libraries. So each and every classes are stored in separate files, and you need not create anything out of the box for just any of the small tasks, such as accepting the input from the user, processing files, creating graphics, etc. So all most of the libraries are quite supported and inbuilt inside your Java package, basically into your JDK. So no need to create anything out of the box for this, smaller application. So you can just use them and get up to speed with your programming. And those are loaded only when needed, so it is not like you just have to load them, all of them. So whatever, whichever is needed, only that are loaded, so that further reduces the time complexity of your code.